Hi guys, good morning. This is Marco and this is Topper tutorial. We are doing dimension analysis. Um, this is 102. We are mirroring it based on University of Ibadan physics, but it can be also extended to other universities. So this is dimensional analysis. So um, before we go into dimension proper, let's first touch what physical quantities and units are. We want to touch what are physical quantities and units. So before then, let me just introduce you to this question because I want to have an open mind, because as you are going through this question, your mind will be open and then you would at least get to understand the basic concept of dimensional analysis. Okay, but I said I want us to go through, before you can fully understand dimensional analysis, we have to know what physical quantities are, and then we have to know some intricacies in physical quantities. Now let's solve this question first. Now, which of this is false? A quantity has a dimension but no unit. B, a quantity has a unit but no dimension. C, a quantity has both dimension and unit. D, a quantity neither have a dimension nor unit. Now, I'm not going to solve this question now because I want us to go through the class and then we'll come back to solve the question together. So that's why I said I want you to have an open mind. Okay. Now, what are physical quantities? Okay, physical quantities are quantities, as you can see, that can remove that can, it's just a mistake, that has numerical magnitude and units. Okay, when you say something has numerical magnitude, what do I mean? It has numbers. Okay, it's just English. It has numbers and units. So, like, okay, i.e., when you want to describe a force, you say 5 Newton. Okay, 5 is the numerical magnitude or the number, while Newton is the unit. Note, you can't just say force is 5 or say force is Newton. Somebody said, okay, which force did the guy applied to on a car that make the car move? And I say, the guy applied a force of Newton. The person will ask you how many Newton, or you said the person applied a force of 5. The person will say 5 watts, because something must follow up. It can be 5 pounds, it can be 5 anything. You understand? So you have to state it as 5 Newton. So it's a quantity, a physical quantity must have numerical magnitude and units. Now, a physical quantity can be divided into three. One, we have fundamental quantities. Two, derived quantities. And the third one is supplementary quantity. Okay, let me have something like this. Okay, so um, if you say we have physical quantity, sorry, physical, so we can divide this one to three. Okay, so this fundamental quantity, we have derived, and we have supplementary. So these are the three quantities. Students are used to two, fundamental and derived. We are not used to this third one, which is supplementary quantity. So we have fundamental, derived, and supplementary quantities. Okay. So fundamental quantity, we all know, are 7 in number. Okay, but in our first year physics, we make use of 5, which are mass, length, time, temperature, and charge or current. Actually, this current or charge issue is still controversial. In University of Ibadan here, we use charge, but in some other schools they use current. So it's still controversial, but people are tending towards charge now. But for this stuff, we'll stick to current. Okay, but as University of Ibadan, it can be either charge or current. So just put that in mind. But basically, that they are teaching towards charge nowadays. So direct quantities are gotten from fundamental quantities. For example, acceleration and work done. Okay. If you look at it, if you go back to this, you see that you see that acceleration, which is a, equals to change in velocity over change in time, and velocity itself is equals to what? Change in displacement, which is x, over change in time. So displacement is measured in meter, while time is measured in seconds. So velocity itself is gotten from physical fundamental quantities. Do you understand? So you now get acceleration is getting from velocity, change in velocity over change in time. While velocity itself is gotten from change in displacement over what? Change in time. So what we are saying now is you get um direct quantity is gotten from fundamental quantity. So if you want to give definition now, you can say fundamental quantities are quantities that cannot be gotten from another quantities. There are seven. The seven quantities cannot be gotten from another quantities. While direct quantities are quantities that are gotten from fundamental quantities. Now, the last one is supplementary quantities. Okay, supplementary quantities are just there are two in numbers. We have plane angle and solid angle. Plane angle and solid angle. Those are the two supplementary quantities that we have. Students are used to the first two quantities, which are fundamental and derived, but the supplementary quantity they are not always used to it. I don't know why. So, plane angle and solid angle is very very important because it's crucial to the question that I asked in this place. I'm still coming to that. So we have supplementary quantities, and there are two, which are plane angle and solid angle. Okay, the units about the units. We know that the unit of fundamental quantity, we all know it. Okay, that of mass is kilogram, length is meter, time is seconds, temperature Kelvin, current ampere, or charge is coulomb. We have amount of substance, which is mole, and luminous intensity, which is candela. So for plane angle, the unit is radian. Okay, and why for solid angle, the unit is steradian. So it's very important to know this. Okay, let's go to the dimension in proper. But before then, let me just state this here because I don't want to go far. I want us to answer that question. Plane angle has unit but no dimension. Plane angle, any supplementary quantity, not plane angle alone. Plane angle and solid angle, they both have unit but no dimension. Okay, plane angle has unit but no dimension. Now let's go back to the question that I asked from the beginning. Which of these is false? Okay, let's leave the A first. Let's go to B. A quantity has unit but no dimension. It's not possible for a quantity to has unit but no dimension. Is it possible? Quantity has unit but no dimension. Is it possible? Answer me, please. Okay, it's normal. A quantity can has unit but no dimension. Look at what I said. I said supplementary angle, they has unit but no dimension. So it's basically correct. It's not false. A quantity has unit but no dimension. So it's only supplementary angle that has unit but they don't have dimension. So B is correct. C, a quantity has both dimension and unit. We know that almost all the quantity that we know all has dimension and unit. For example, we have force that has dimension and unit. We we have acceleration has dimension and unit. Almost all the quantity that we have has dimension and unit. Now, another one is that a quantity neither have a dimension nor unit. Yes, it's normal. For quantity that divide itself, we'll still come back to that. When I treat type of dimension, we are going to that now. For quantity that divide itself, for example, now when you talk about refractive index, okay, velocity of light in air or in vacuum over velocity of light in medium. So velocity of light divided by velocity of light, so it cancels. So the quantity does not have dimension, does not have unit. Another example is coefficient of static friction, which is is frictional force over normal reaction. Or yes, so frictional force is in Newton, normal reaction is in Newton. They cancel each other, so they have neither dimension nor unit. Another one is velocity ratio. Another one is mechanical advantage. Okay, all of them, there are many like that. So they don't have dimension, they don't have unit. So but a quantity that has dimension must have unit. Any quantity that has dimension must have unit. It's very important. Any quantity that has dimension must have unit. So A is the correct answer. A is false. A quantity that has dimension must have unit, but a quantity that has unit may not have dimension. It's very important. This A and B is very important. A quantity that has dimension must have unit. B, a quantity that has unit may not have dimension. So it's very important. Please take note of that. Now let's go quickly to dimension. Okay, I said first, what is dimension, and how do I want to personally, how do I want to approach it? Okay, I will tell you how to approach it later. But let's just say, what is dimension? What is dimension, and how is it different to units? How is it different from units? What's different between dimension and units? Now, dimension are physical quantities that can be measured. Dimension are physical quantities that can be measured. Or you can also say, because physical quantities are quantities that has numerical magnitude and units. Okay, so dimension are just representative of physical quantity. Because if you want to measure this room now, in my room, you can say my room is 3 meter. Okay, 3 is numerical magnitude and meter is what? Unit. So dimension are physical quantities that can be measured, but units are just arbitrary name given to for agreement purpose. For example, now, okay, for example, we can say, okay, the length of a room can be in yard, can be in feet, but we all agree that we want it to be in meter. Okay, so when you go and measure, when I tell somebody that is in, I'm a physicist that is in US, that the length of my room is 3 meter, the person understand quickly, because we use the same, we agreed on that measurement. That's what we call it. We said it's arbitrary. We give it a name, so we know that, okay, the unit of the basic unit, the fundamental unit of meter of length is what? Meter. The fundamental unit of um force is Newton, not pounds. So it's an arbitrary name given to, it's just a name, it's not, doesn't have significance, it's just a name given to it so that we can all agree. But dimension are physical quantity that can be what? Measured. So for you to understand deeply, let's move to the type of dimension. We have 4 types, which I'm trying to be fast so that I can limit your data so that you don't use more data. We have dimensional variable, we have non-dimensional variable, we have dimensional constant and non-dimensional constant. So I'm going to come back and explain this further.